All right, so here we're back on equations of line special forms. So the linear equation in the form y equals mx plus b is called the slope-intercept form for a line. And we talked about that before, where that's the slope and that's your intercept. Now, when x is equal to 0, basically that goes away and you get y equals b. And the graph of y equals mx plus b crosses the y-axis at the point 0b, where the constant b is the y-intercept, okay? Now, when x is equal to 0 and you have the point 0b on the graph, and say x is equal to 1, we plug in 1 there, we get 1 comma m plus b is on the graph. Now, how do we find the slope? Well, we have those two, so we take this minus this over that minus that, your rise over your run. And when you do that, those b's cancel and you just get m over 1 or m. And so that shows you then that that's going to give you the slope, and so therefore m is the slope of the line given y equals mx plus b. Now, again, this is going to be a very important formula for you to use. The other one, remember, we had before, kind of the standard form, was ax plus by equals c. And so these two forms we can interchange and go back and forth between. So sometimes we're going to go this way, sometimes we're going to go this way, depending on what we're given. And so slope-intercept form or the standard form are the kind of the two equations we have. Now remember, this is your intercept, so it's going to be 0 comma b. And this is going to be your slope, so it's going to be equal m equals whatever it is, a half or 2/3 or whatever it is. And so you can easily find your slope and your intercept, and from that you can graph it, because you can first graph this point, and then we know our rise over our run, and we can graph another point and even another point, and we have 3 points, we can make our line out of it, and that's how we can graph things. So usually if they say, okay, here's an equation, graph it, and you have to do it by hand, well, first we're going to go and put it in this form, find our intercept, find our slope, plot our point, go and use our slope to go up and down 2 points, one each direction maybe, and then draw your line, and that's going to be how you're going to graph your line. So first example, find the slope and intercept of this. Well, again, guess what that is? Well, that's your y-intercept. So it's going to be 0 comma 3. And what's your slope? Well, slope is just equal to a -2. And so that's really as simple as it is. That's all they're asking here, and that's all we have to do. Well, what about this one? Find the slope and intercept and then graph it. Okay, well, our slope and intercept, our intercept, again, is going to be 0, 3, and our slope is going to be a -2. Now, remember, you want rise over run. So sometimes you want to rewrite it as a -2 over 1, or you could do a 2 over a -1. And then here we have our rises going down by 2, and here we have our rises going up by 2, and then the opposite, here our run is 1, here our run is -1. So all three of these represent the same thing, and that's going to depend on how you want to graph it. So 0, 3. So 0, 1, 2, 3, that's going to be our first point. Now let's use, let's call it slope 1 and then slope 2. We can do different things, but we can do it this way first. So we're going to go down 2. So I'm going to go down 2, and we're going to go right 1. Go right 1. So that's going to be 1 point. Or we can go up 2, left 1. And that would be another one. And we can see that all lies on a line. Now, instead, we could have gone, instead of down to right 1 and then gone back up, this way, we could say, okay, well, let's go down 2 more and right 1. And, from there, we could go down 2 more and right 1. Or we could have gone here, instead of just going up 1 time, we could have gone over 1, up 2, over 1, up 2. And in any case, I won't be able to draw a straight line even with this many straight points, but that would be what your line is. And again, all you needed was the slope-intercept form. So we had their intercept and we are slope, and we start with their intercept and move left or right depending on what we want to do there. All right, so an equation of the line of slope m that passes through the point x1, y1 is, and this is going to be the point slope form. So what we have is we have some point x1, y1, and we're going to plug it into this equation. So we're going to plug in our y1, we're going to plug in our x1, and if we know our slope, we plug it in here. And so then we have this, which is called the point slope form from the point slope form, we can go to the y equals mx plus b, or we can go to the ax plus by equals c. It depends on what they ask you for. First, you have to get it to the point slope form to get an equation, and then you can go here, or you can go here. All right, so I wrote over that, but that's okay. So this form is useful since it allows to find an equation for a line when the slope and the coordinates of a point on the line are known. Now, sometimes they'll give you 2 points. So they might give you x1, y1 and x2, y2. Now, if you do that, guess what? We can find the slope here. So if they don't give you the slope, they give you 2 points, you can find the slope and it goes here. Use one of the 2 points, it doesn't matter which one, as your point in the point slope form, and then you can solve for an equation that way as well. And this is what I just kind of was stating here. You just have to find that slope using the 2 points and then one of the points, and you can put that into the point slope form and you can get your solution that way. All right, so it says, find an equation for the line with a slope 1/2 that passes through the point 2, -5. So remember, we have to use y minus y1 equals m times x minus x1. So 2 is going to be x1, minus 5 is going to be y1. So we're going to have y minus a minus 5 equals 1/2 from here, and then x minus 2. And so that's going to be y plus 5 equals, now I'm going to distribute this. So it's going to be 1/2 x, distribute that, that's going to be a minus 1. All right, and so it says it wants it in the standard form. So that means I better take the x's over here and the numbers over here. So I'll subtract 5, subtract 5, subtract 1/2 x, subtract 1/2 x. So it looks like a minus 1/2 x, and then plus y equals, and it looks like a minus 6. Okay, so that is what we have. Now, we could have also taken everything the other way. We could have taken the y over here and the 1 over here. And if we did that, what would we have? Well, we would end up instead with 1/2 x minus y equals 6. So you could come up with 2 different answers depending on which direction you went. So that's kind of a key to remember. There's not just one correct answer, there's actually 2 possibles. And you can get from one to the other. If you multiply this one by a -1, you get to this equation here. So either one of those would be the correct answer as far as the final form ax plus by equals c. So that would be what we would have there. Now, if they wanted it in the slope-intercept form, then I think at this point here, when I had this, all I would have to do is subtract 5 over here, and I would get y equals 1/2 x minus 6, and then that would be my slope-intercept form. So 0, -6, and then I could go up 1 over 2 or down 1, left 2. So that would be a way to actually graph that equation. All right. Let's see here. Find an equation for the line that contains the 2 points, and they want it again in the final form ax plus by equals c. All right, well, we don't know the slope. So first thing we're gonna have to do is we're gonna have to find the slope. So if we take a -7 minus 4 over, and then we have a 4 minus a -3, so that's going to be what? A -11 over, and that's going to be 4 plus 3, that's going to be a 7. And so that should be your solution there. All right. And so now we can use one of the points. Again, it doesn't matter what point. We could use this one, or we could use this one. And let's use, I don't know which one looks like it's going to be easier. Let's use the second one. I don't know. It doesn't really matter. And so we're going to use y minus, and this one is going to be a -7. And that's going to be equal to our slope, which we found was a -11 over 7 times x minus, in this case, 4. And so when we do that, what do we have? Well, we have y plus 7 equals a -11 over 7 plus, now it looks like we're going to have what, a 44 over 7. Okay. Oh, we better put our x here. We're going to be in trouble here in a little bit. All right. And so let's see here. Now that should be good. And so now what we have to do is we have to just simplify. So let's take this over here. Oops. and subtract our 7. And so it looks like we're going to get plus 11 over 7x plus y equals, and here we have 44, and then that's going to be if we multiply that by 7 over 7, that's going to be what, a minus 49 over 7. And so it's going to be a minus 49 plus a 44, so that's going to be a minus 5 over 7, if I did the math right. And so that looks to be that. And so that would be, one possible. Now, I hadn't said this before, but sometimes when they want these A's and B's and C's, they don't want fractions. So even though over here I said that was probably the final answer they'd want, sometimes they want something different. They don't want A, B, and C to be fractions. They want it to be whole numbers. And so you kind of have to be paying attention to what they want. And so when you do that, if we multiplied this whole thing by 7, that would get rid of all the fractions. And so we'd have 11x plus 7y equals a minus 35. Okay. Wait, not a minus 35. I forgot that should be just a minus 5. Don't have any erasers, so we'll just make that a minus 5. All right, so then because that cancels that, we just have the minus 5 there. And so that would actually be a more perfect form because we have the whole numbers. And again, it all really depends. Most of the time they do want this without fractions, but sometimes you can have a fraction and it's okay. And in this form, you always have to have a fraction because you want it to be solved for y. This one, if we did it like we just did here, if we multiplied this whole thing by 2, that would give us x minus 2y equals 12. Or in this case, if we multiplied this by 2, that would give us a negative x plus 2y equals a negative 12. So these would be the more correct answers. These would be also good answers. If it did it on a test in class, it'd be this way. Probably if you're online, this would be the way they'd want it in the homework section there. So again, this would be probably the most correct answer when we use the whole numbers A, B, and C. All right, so these are the summary of the possible things. We have our standard form, ax plus by equals c. A and b can't both be 0. We have the slope intercept, y equals mx plus b. Here our slope is m, our intercept is the b. We have the point slope form, which is one we just learned last, y minus y1 equals m times x minus x1, where you have a point x1, y1 and a slope m. Horizontal line, that's just y equals b, our slope is 0. And a vertical line, x equals a, and our slope here is undefined because it's going to be a vertical line. All right, so let's do an example real quick before we move on here. So a company finds an office equipment that was purchased for $20,000 will have a scrap value of $2,000 after 10 years. Using straight line depreciation, which is linear, find the linear equation that relates the value in dollars to the time t in years. All right, so what do we have here? Let's see, yeah, okay. So what we have is time equals to 0. The value is equal to $20,000. When it was purchased, it was $20,000. And at time equals t equals 10, the value is going to be equal to $2,000. Okay. So find the linear equation that relates value to time in t. So basically, we're going to have our value over our time is going to be our slope, and that's going to be our straight line depreciation. So what we want to do is we're going to take our change in y over the change in x. So we have, if we want to look at this, our points at 0, 20,000, and 10, 2,000. And so plugging those in, we'll have for a slope, it's going to be equal to, and again, it doesn't matter which one's x1, y1, x2, y2. So if we take 20,000 minus 2,000 over 0 minus 10, that's going to be what, 18,000, oops, too many zeros, divided by a negative 10. And so that's going to give us a negative 1,800, okay? And that's going to be negative $1,800. What? That's going to be negative $1,800 per year is what's going to happen. That's your depreciation. It's decreasing by $1,800 per year. And so if we wanted to write this in a form, say y equals mx plus b, what we're going to have is we're going to have some v of t, because instead of x's and y's, now we're using v's and t's, and v is going to be your y, t is going to be your x. So this has to be kind of a function. And so v of t is going to be what? Well, we're going to have our slope, which is negative $1,800 per year. And that's going to be times what? Well, that's going to be times our time, depending on what time it is. We plug in 0 years here and 0 here. What do we get? Well, we should get 20,000 for our intercept. So that better be 20,000 there. Okay. And so that would be our value at time t. Okay. So if they ask for the final function, that would be your function. So that's going to be the value in dollars after t years. So that would be kind of the units on this one as far as what it goes for. So you need to have most equations or functions we have in this class, you'll have to have some kind of a thing like that. But the actual equation is just going to be that, or your actual function is going to be that. So first we had to kind of find our slope. Then luckily we had an intercept, so we could plug it in directly and plug the slope in. We have y equals mx plus b, and instead of y's and x's, we have v's and t's, and we made it a function in this case. All right, so let's stop there.